Chapter 5. All right, cool. I really don't want to do this, but I will because this stuff sucks. So we're determining oxidation slash redox reactions. So we're going to start out by identifying the charges on each reactant and then determine the charges on the products. So the way that we do that is we look at what is attached to each other. So here in the first one, in both cases, it's only one element attached to itself in oxygen's case, and in magnesium's case, it's only one element. So when there's only one element, the charge is always going to be 0. Okay? But now on the product side, we have a different case. We have magnesium attached to oxygen. So there's going to be charges. So oxygen, we know, has a -2 charge, and then magnesium, which is a metal, has kind of a variable charge. So we can determine from oxygen's -2 charge that magnesium is going to be +2 because it wants to balance out to be a 0 charge. Okay? Oh, and by the way, balancing, that's balanced. So now for oxidation and reduction, we draw an arrow from the magnesium on the left to the magnesium on the right, the oxygen on the left to the oxygen on the right. Now, oxygen's charge went from 0 to -2. So it lost charge, which means that it gained electrons, which we know means it's reduced. And magnesium gained charge or lost electrons, which means oxidized. And then to determine the agents, we just follow the reduced back, and that's the oxidizing agent. Follow the oxidized back, that's the reduction agent. So O2 is the ox agent, and Mg is the reduction agent. All right, so the next one, once again, we just have an element on its own, aluminum, so that's going to be 0. HCl, we know that chlorine is -1 from the periodic table, therefore hydrogen is +1. We go to the right side, chlorine has a -1 charge, -1, -1, because there's 3. I wrote -1 3 times, so it's a total of a -3 charge. So now one aluminum has to cancel out that -3 charge, meaning that the aluminum is +3 charged. And then on the right here, we have hydrogen all by itself again. So once again, it has just a 0 charge. So let's draw the arrows from the hydrogens. Draw the arrows from the aluminum. So aluminum gains charge or loses electrons, which means it's oxidized. The hydrogen loses charge, which means it's reduced because it gained electrons. And then we just flip it, so the HCl is oxidation reaction. HCl is the oxidization agent. And then Al is the reduction agent. All right, now to the third one. Do the same thing. We have zinc over here all by itself. We know it has a 0 charge. Oxygen's -2, -2. Therefore, manganese is +4. On the right side, we have oxygen at -2. Therefore, zinc is +2. -2, therefore +3, +3. Okay, so we draw the arrows from left to right again. Zinc is gaining charges or losing electrons, meaning it is oxidized. And magnesium is losing charges or gaining electrons, therefore it's reduced. What I mean by losing charges, on the left side, manganese has a +4 charge, on the right side it has a +3. So it is going from 4 to 3 or losing 1 charge. On the left side, zinc is going from 0, and on the right side it has 2, so it's going from 0 to 2, and it's gaining 2 charges, which means it's losing electrons. So let's go ahead and balance this real quick, which I didn't plan ahead to do. I just kind of threw the balancing in as an extra step of practice. Yeah, I don't know what to do. So let's see here. Let's go up to the AL HCl again. So let's just go ahead and try and balance it in my head. 2, and then H2 is going to be match 6. It has to be 3. Yep, so that one's right. So let's see here. Zinc matches on both sides. Oxygen does not. We have to put a 2 here, which means it matches. Yep, because oxygen's 4 on the right side, 4 on the left side, 2 manganese, 2 manganese. Perfect. All right, let's move on to the next one after this next video.